All right, now we're recording. All right, guys. And I know I put in here the last few days, but we're talking about before testing week. The only composite argument formula that you know at the moment is this one. Cosine, and I think you guys know A minus B. Is this the one that we covered last week? Cosine A, cosine B, plus sine A, sine B? Or 2 weeks ago before testing week? That's the only one you know. We're going to derive all the others from that. I don't know if you remember, but we derived that one from the unit circle. We did the distance formula from quadrant 1. No big deal if you don't remember. And this is just an overview. You already know. It says what function is an odd function and which function is an even function. Remember that an odd function is symmetric about the origin, so flip, flip. So this one here is odd. This one is an even. And tan is, again, an odd function. Let's see. If the cosine is even, then the reciprocal of cosine is also even. The reciprocal of cosine is secant. So notice all those rules are right here. Cosine and secant are even functions. And because they're even functions, you have this property that cosine of negative x is equal to cosine x. And hopefully you can see why. See, cosine of negative theta, the y value is the same thing as cosine of theta. See, so it's the same. That's why there's a plus minus when we do inverse cosine. All right, I think we're good. Then this property is for odd. So sine of negative x is equal to negative sine of x. I don't see any issues there. Are we okay so far? Okay, so turn the page. All right. Cosine and sine differ by 90 degrees, or pi over 2. You guys already know that. Let's just draw a right triangle. I think it's pretty easy. And I'll put it, that's my right angle. And I'll call this alpha, and I'll call this beta. That's a capital B kind of. And I'm going to say that's 3, and I'm going to say that's 4, and I'm going to say that's 5. I want you to observe something. SOHCAHTOA. I want you to observe that because the interior angles of a right triangle, or any triangle for that matter, unless it's non-Euclidean, all three angles add up to 180 degrees. So that means alpha plus beta equals 90 degrees. Cool? Okay. So if I were to tell you sine of alpha, you were to tell me 4 over 5. Right? All right, now check this out. If I told you I want another ratio that's also 4 over 5 besides sine of alpha, you would probably tell me cosine of beta is also 4 over 5. Cool? Or not cool? Now, do you agree? Let me see if you guys agree. Do you guys agree that beta is nothing more than, let's see, than 90 degrees minus alpha? Is that a true statement? What do you guys think? Is that a true statement? Yeah, guys, this is 90 degrees, and this is alpha. So 90 degrees minus alpha. Remember, all three of them add up to 180. So, Chavez, what are you talking about? Alpha plus beta plus 90 equals 180. See? So if I were to tell you to get beta by itself, you would go minus 90, and then minus alpha, and you would say beta is equal to 180 minus 90, that's 90 degrees, minus alpha. Cool or not cool? So from this, check it out. Look what happens when I plug it in here. So sine alpha is equal to, what is beta? 90 minus alpha. Cosine 90 degrees minus alpha. OMG. Are we okay? Because this is true, I can also say that cosine of alpha is same thing as sine of 90 degrees minus alpha. And relax, you do have these formulas in case you don't see it. If you don't see what we just did, guys, relax. All you got to know is all this right here is true. And hopefully you saw the little proof that we did. Hopefully all that made sense. Did it kind of make sense or no? I see some yes, I see some I don't know. Okay. All right. Okay. I think we're okay so far. By the way, the pi over 2 is the same thing as 90 degrees. We're still cool? All right. So check it out. Finally, we get to some really fun stuff. This is going to be so much fun, guys. It is. I know you guys are like, okay, stop. Okay. All we know right now, the only thing we know is cosine A minus B. That's all we know. Cosine A, cosine B, plus sine A, sine B. What I want to derive this one. And I know what you're thinking. Maybe you're saying, Chavez, I don't want to draw that unit circle. I don't want to find no distance, blah, blah, blah. Relax. We're going to do what is called the gamer move. It's a hack. None of you guys game? No? Okay. You know that you can cheat like in games by having hacks? Okay. It's the same thing. We're going to do a hack. So I'm going to write cosine. This is what I want. I want to figure out what cosine A plus B is. So here's my hack. I'm going to do cosine parenthesis A minus, this is the only thing I know, A minus a negative B. Look at my hack. Is cosine A minus a negative B the same thing as cosine A plus B? It is. Now look what I'm trying to say. That this angle here, I'm gonna put it like in green. So instead of writing B on all these, I'm gonna write negative B. Do you guys see that hack? I'm just following this. I'm just following that. So I'm going to be going ahead and writing, instead of a B, I'm going to put negative B. So here's what I'm going to do. Equals, and I'm just going to follow my rule up there. Cosine A, cosine of negative B. All I'm doing is following that. See, that minus is that minus. Plus sine A, sine of negative B. Catch up to there. Are we cool? What do you guys think? Nothing crazy, right? What is cosine? Is cosine odd or even? Even. Cosine's an even function. Now, because cosine's an even function, I can write this as cosine A, cosine B. Plus, what about sine? Is sine odd or even? Odd. So I'm going to write sine A. I'm going to open up a parenthesis. Because it's odd, all I'm doing is following this up here, guys. All I'm doing is following this right there, see? Because it's odd, I'm going to write negative sine B. Are we okay so far? What is positive times a negative? Negative. Cosine A, cosine B, minus sine A, sine B. And look, there it is, guys. We just came up with a rule. We just came up with this rule. Cosine of A plus B is equal to cosine A cosine B minus sine A sine B. Underline. Now you know two of them. Was that complicated? Was it complicated, guys? No. Bless you. It can be done. You can do it. You're smart. These are the type of questions that UH gave. Okay, ready? And I know it says, does Universal Math Gang sign? At the time, I thought I was being funny. Delete that. All right. We're going to see if we can do this one right here. Sine of A minus B. We're going to do another hack. All I know is these up in the top. That's all I know. Cosine A minus B and cosine A plus B. That's all I know. So here's the hack that we're going to do. Write sine A minus B. And the hack that I'm going to do, if you have colored pencils, it is a good place to have colored pencils. I'm going to group A minus B as an angle. And I'm going to turn this into cosine. All I'm doing is this up here, guys. All I'm doing is this one right. Let's see, which am I going to do? I'm doing this one right here. That's what I'm doing. I'm grouping the a minus b as a theta, as one of the angles. So I'm going to write it like this. I'm going to write it cosine, giant parenthesis, 90 degrees minus, here's my green one, a minus b, close, close. Is everyone okay so far? All right, I'm going to distribute this. I'm going to distribute that. Cosine, 90 degrees minus a. Negative times a negative is a positive. I can choose how to group however I want. I'm going to group the 90 with the a like that. That's going to be as one angle. Are we okay? So you can already see with the hat, guys. Look, this plus is going to be that plus right there. Do you guys see that? So here we go. I'm going to put an equal sign, and I'm going to write cosine, and I'm going to open a parenthesis, and I'm not going to write cosine A. I'm going to write cosine of 90 minus A. Close it. And then it tells me cosine B, which I will gladly oblige, cosine B. Are we okay with that? Then it says it has a minus there, so I'll put a minus. That minus is this minus. And I'm going to write sine. And I'm not going to write sine of A. I'm going to write sine of 90 minus A, close it, sine of B. Are we okay so far? All right. Now look at this, guys. I come back. Cosine of 90 minus A is something. Well, let's see. What is it? What is that cosine of 90 minus A? Cosine of 90 minus A is the same thing as just saying what? Sine of A. So I'm going to write sine of A, cosine B, minus, that minus is that minus. And then sine of 90 minus A is the same thing as saying, like right here, it's right there, sine of, right here. Sine of 90 minus A is the same thing as saying cosine of A. So minus cosine of A, sine B. There, we just got another one. Another one, as DJ Khaled would say. Well, I don't know. Do you guys know who that guy is? Okay. I don't know. I thought maybe it was a millennial thing. Sine A minus B is nothing more than sine A cosine B minus cosine A sine B. We just got another one. Cool or not cool? All right. Take a guess. I think you have enough experience, I think, that you guys can figure out this one without having to do any more hacks. Take a guess for what do you think that one is? I don't know, Chavez. Well, I don't think I have enough experience. Well, let's see. Look what we know so far. I'm going to erase these green ones here. If we know cosine A minus B is cosine A cosine B plus sine A sine B, and we know cosine of A plus B is cosine A cosine B minus sine A sine B, and we know, sine of A minus B is sine A cosine B minus cosine A sine B, so then sine A plus B must be the same thing except what? The minus to a plus. Sine A cosine B plus cosine A sine B. You guys are going to be future doctors and future engineers, guys. You got to be able to make split-second decisions and make interpretations and make educated guesses. How do we feel? Do we feel okay? All right. Here is what you're going to be doing as an assignment. And okay, I want to give credit where credit is due. This question came from UH. It was from the math competition. Do you guys remember the math competition that we took recently? All right. I don't want you guys to be discouraged. I want to make sure that you know those kids that are getting close to perfect scores. Because by the way, first place was 31 out of 34, whatever they only missed 3. They're getting these questions correct, and I want to make sure that you know you also can get this question correct. So what's the difference between that kid and you? Nothing. It's just that they have been exposed to these type of questions. But now you are also getting exposed to these type of questions. So when you get this question, remember, by the way, you don't need a calculator to solve this. Not this one, at least. They give you questions that you don't need one. When you get this question, do you just freeze? You're like, I don't know what to do. Or do you say, you know what, I know enough to get it done? We know enough, guys. So look, this is how you tackle it. This is what's going on in your head. You see it, you're taking a competition, you're doing a UH math competition, and it says solve the equation sine 5x cosine 3x minus cosine 5x sine 3x equals half between 0 and 2 pi. And then you have answer choices A, B, C, D. And then you look at it and I'm like, man, I don't know, have I ever done this? But here's why you're going to be so smart. You look at it and you're like, wait a minute, I see a 5x and I see a 5x. I see a 3x and I see a 3x. And immediately you start thinking, that looks like sine A cosine B minus cosine A sine B. Does it not? Can I turn this into either a single sine or a single cosine? Can you? Yeah, we just talked about it right now. This is sine, cosine, cosine, sine. I look up at my little formulas. Hey, look, there it is. Sine, cosine, cosine, sine. There's a minus sign, so it must be this one in red. Do you guys see that? So then, look, all that reduces to sine, one sine, A minus B. So I'm going to go sine, and then the A is 5x, and then the B is 3x. And all that equals a half. Can you at least do that? Can we do that, guys? Okay, perfect. Now look, everything else is just stuff that you've learned throughout the semester. What is 5x minus 3x? So I'm going to write sine of 2x equals a half. I know you know how to do this question, guys. The rest is just the first semester stuff. How do I get rid of the sign? Arc sine. So I'm going to write 2x equals arc sine of a half, and then plus 2 pi n, because if you do a whole 2 pi, you're back in the same location. Now, before I start, here's where I would write 2x1. 2x1 equals, in the unit circle, where's the first time you hit a half for sine? Remember, sine's a y value. Not pi over 4. You guys don't remember? I heard some pi over 6, so here it is. Pi over 6 plus 2 pi n. And then I'm going to have to divide by 2, right? Divide by 2, divide by 2, divide by 2. So you're going to get x1 equals pi over 12 plus pi n. So here are my answers for x1. x1, one answer is pi over 12, comma, what's another answer? Turn this into 12 over 12, guys. N is any integer. What's 12 plus 1? 13 pi over 12. So I got two answers there. There's two more. I'm gonna turn the next color blue. I'm starting from here, guys. So I'm gonna write again 2x. I guess for now I'll write 2x, and the next step I'll write 2x2 equals arc sine of half plus 2 pi n. Where else is sine a half on the unit circle? There it is. So I'm going to write 2x2 for second equation, 5 pi over 6 plus 2 pi n. I'm going to divide all of them by 2. Hey, no yawning. That's a demerit. This is not exciting. How do you yawn with this stuff? I'm super tired, but I'm like loving it. 5 pi over 12. I felt like McDonald's there. Plus pi n. I need a common denominator. That n is any integer. 12 over 12. Here are my answers. x2 equals, one answer is 5 pi over 12, comma, another answer is 5 pi plus 12 pi, 5, 6, 7, what's that, 17 pi? All right, give me my answers in order. X equals, I have them here in black, this one's my very first one, pi over 12, comma, the next one's going to be this one, 5 pi over 12, comma, the next one's going to be this one, 13 pi over 12, and then the last one's going to be the 17 pi over 12. Here are my answers in order from smallest to biggest. And then look at all this beautiful math that you just did. This math is a lot like art, guys. Look how beautiful that looks. And you guys are going to be the future engineers. If you're wondering, man, I'm never going to use this. When you become an engineer, you're going to be dealing with these signals all the time. How do you think your phone works? You're going to be using Fourier transforms to analyze. And okay, I'll stop talking. Cause I don't know. Have you guys heard of Fourier transforms? Never? You never heard of Fourier transforms? How about Laplace transforms? Oh man. Okay. Do you guys don't care like of how your cell phone works? You just, as long as it works, you don't think about like what signals, like how it gets to pick up the signals and how your internet works, internet protocols, packets. No? You never? Okay. All right. We're good, guys. All right. One more. And remember, if all this stuff is just gibberish to you guys, we're just verifying, we're telling you where these formulas come from. They're all on the last page, so we're almost done. One more. Tan A minus B. So here we go. I'm going to write tan A minus B. Remember that tan is sine over cosine. So I'm going to write this as sine A minus B over cosine A minus B. Are we still okay? We now have composite argument properties for both. By the way, Delta Math calls them angle and difference sum, trig. So you'll see what I mean. Sine A minus B. So here we go. Sine. It's easy to remember. The sine one starts with a sine and it toggles. Sine A cosine B minus the sine one keeps the sine. Cosine A sine B. All over the cosine does not toggle. Cosine A cosine B. And then instead of a minus, it's a plus. Sine A sine B. Are we okay so far? All right. What do I want? I want a 1 where this guy is at. The only way to get a 1 there, is to divide by cosine A cosine B. Does that make sense to you guys? Okay. So I'm going to divide by cosine A cosine B. Now this is magic. You can't just divide that one term by cosine A cosine B. You got to divide everything by cosine A cosine B. Because I want to keep it the same. I want everything to be equivalent. Cosine A cosine B, cosine A cosine B, cosine A cosine B. Don't worry, I'm going to write it in a little bit super big. So here's what I have now. So I'm going to rewrite it. I'm going to write sine A cosine B divided by cosine A cosine B minus, and then I have cosine A sine B divided by cosine A cosine B. All this is over cosine A cosine B divided by cosine A cosine B plus sine A sine B divided by cosine A cosine B. All we're doing, guys, is just basic algebra 2 stuff. I know that this is going to turn to a 1. That's going to turn to a 1. I see cosine B in the top, cosine B in the bottom, and the upper left-hand term. Those cancel out. I see cosine A in the upper right-hand, cosine A. Those cancel out. In the bottom right, I see, actually none of them cancel. So here's what I have, finally. What is sine A over cosine A? That's the same thing as, such letter T, tan, that same argument, tan A, minus, what is sine B over cosine B? Yeah, tan of that argument, tan of B, over, and it's all good, no worries, 1 plus, and again, look, sine A over cosine A, that's tan A, and sine B over cosine B, that's tan B. And there it is, guys. Let me put the equal sign better in the middle. We just verified what tan of A minus B is. So tan of A minus B is nothing more than tan A minus tan B over 1 plus tan A tan B. And you guys should be proud, at least I hope. Let's catch up to there. So today, when you go talk to your parents, I want you to tell, I would like for you to talk to your guardians or your adults. Look, mom and dad, or look, adult guardian, look what you are able to do. You just derived all of these formulas from scratch. All of them. We told you where every single one of those formulas comes from, so they are no longer a mystery to you. Isn't that cool? Or you guys don't think that's cool? You just want me to give you the formulas? Okay. All you're doing today, guys, you might need a calculator because not all of them are perfect radians. If it's a perfect radian, leave it in terms of pi. All you're doing today is like this example. I give you something like this. You're going to turn it into one of these, and then you're just going to solve. And solving is just like stuff that we've been doing the last semester. Are we okay with that? And of course, you can work in groups. First, sixth period did it yesterday. They all finished it. So you guys have a whole hour to get it done. There's only 6 questions. So you should be able to finish it because there's only 6 of them. Cool or not cool? All right, that's it, guys.